Let me show you one more. Let's go back to overview, and in this particular data set, and again, this is what the reasons why we did it this way. Look at month. Let's go look at month. Look at November. Remember, November was a high selling month. We know that. We saw that in the data. Let's go and see why does this do better, right? And right here, I can see that, again, this is the global average for November. It's way high. It's 802. November by itself is a positive, is a good selling month. There's a lot of big, large daily quantity numbers associated with any record that has November. And I have a lot of combinations here. And we can see here like promotion coupon occurs 8% of the time globally. Okay, but change 23.7. Okay, what is this? All of this math trying to say? And this is very interesting, which is it's trying to say here is, you remember from promotions, that chart we had coupons. For promotion, we had four kinds, right? We have coupons, we have display, we have none, and we have mail-in. Mail-in was very bad, but if you recall, you can go back and look at the chart. But the coupon, there were two bars with big numbers. One of them was coupon. So coupon is a very good thing. It affects daily quantity in a positive way. And what we're doing in November, you could have assumed that it's a good selling month, Thanksgiving, etc. But that's not particularly the reason why November is very high. The reason is this little statement right here, which is you're doing a lot of more coupon in November. That's pretty much what it's saying. It's saying like over the 30,000 records, if you distribute your coupons across, in general, you're doing about 8%. But when you do, 8% across, the combinations of rows. But when you go to November, when you look at just November, all the rows that have November, and you look at the type of promotion, significantly coupons are way much more by that amount. And this is the beauty here, that everything is backed up by the numbers, by the math, by the statistics. And in this case, it's almost you can think about almost 3 more times. And because of these cases, daily quantity increased to 58. So it's not just that November is a great month because of Thanksgiving, whatever. There's something inherently being done here. Now, we don't know if it's the business. This is where I have to go back to the marketing or the business team and say, hey, is this something we're doing consciously? We are, doing a lot of coupons in November, or is it just something that, we were not aware of, and maybe we can reserve some of these coupons and use them in the month that we're not selling a lot. So these insights, again, they're not easily discovered in a general dashboard, and they are not easily even, let's say, even in this story. So, not easily, representing themselves in the chart itself. What I'm trying to say here is like, you need to spend time. You need to spend time to look at the insight and look at why does this do better, analyze these component driver analysis, and kind of go over everything that chart might be saying or not. Here's another example, by the way. To city is Detroit and promotion is mail-in. This is a little bit way much more clearer. Like you can see, it's a positive thing, although mail-in is not so good. And this, again, you should see it right there on the insights. In the insights right here, city Detroit and mail-in is 6.5 globally, that combination of Detroit and mail-in, but it changes to way much less when the month is November. So for Detroit, in November, we barely do any mail-in, and that's why it's giving me that boost in November for that particular month in November. So again, these are all kind of different combinations of the values of the fields that the algorithm goes through and kind of gives us all these insights under here. And obviously, in this particular scenario, it's a small retail scenario. We can relate to it, but you can imagine if this is opportunities or cases or something different, a custom object, custom use case, where you will need the business relevance to understanding these insights. Okay, so I am going to skip the prediction model for a bit and go for, you can either go to recommended updates where you can look at what are the updates, strongest predictor, outliers, duplicates with explanations, or the same message, the same thing you see here, we can go and get from edit story, because you can see the data alerts right here. So I am trying to think about, okay, well, this is the output variable I'm trying to maximize. Is give me an outlier warning. Okay, that's interesting. Give me a strongest predictor. What's a strongest predictor? It gives me a duplicate. So without, again, digging too much deep into the statistics behind them, outliers, if I select this variable outliers and go to settings right here, I can see that across my 30,000 records, I have daily quantities. And most of my daily quantities are between 0 and 500. But I have some extreme values at, some stores, at some rows, I sold 3,000 that day, or 4,000 or 5,000. So what it's trying to tell me right here is these probably are outliers. Why we want to flag them? We're going to talk about model metrics in a second. But these might be outliers, and it might be a good thing. It is usually a good thing to take them out and focus on my normal behavior, not my once in a while behavior. So, for example, maybe I could go back to the business and say, hey, I found this in the data. Is it usual for you to sell a lot, 2,000 on a record or 3,000? Maybe the answer is going to be back, oh no, that was an exception. We had maybe a store that was closing or a special event, and then you will take that decision to limit the filter to maybe up to 1,000 or 2,000, or you can just go with the message right here. It says 2,500, almost 2,400. And that's one way to look at it. And of course, the next way is anytime you do these changes, you're going to go and check the model metric, which again, I'll show you in a bit. But it's a combination checking with the business, combination checking with whatever setting I change here, whatever I exclude or include. Is it affecting my model in a good way? Is it producing a more accurate model, more accurate prediction, or is it not doing that? And that's what we're going to discuss later. And you can see here, like, how do you want to bucket the data? So that's how you're bucketing. So if it's a number, when we take the data and Einstein discovery, there's a bucketing of these values, especially for numbers, and you can control that if you want. And so that's for outliers, for example. If you go to strongest predictors, it's telling me, well, this variable sounds like it has a direct influence, or it can you can consider it in a way telling me what's the outcome. So if you remember in that use case video where we talked about the condition, do not include churn reason for the customer. If you're trying to study if a customer is going to churn or not, well, if you have the churn reason, that means the customer churned, and that's a direct indicator that the customer will churn. You will see maybe 100 or 99% strongest predictor. And this is what it's trying to say, is like, sounds like you tell me the city and I can tell you what's the daily quantity. And in this particular scenario, a 35 number is not enough to take that decision and say, okay, exclude it. I do have to check again with the business, or more likely I'll check with the model metrics and see if I exclude this, if I uncheck this variable from here and then run the story again, do I get a better model or a less accurate model? Also notice numbers are bucketed. The dimensions or categorical variables, you might hear this term again. They have the features or the values right here, and I can sort by, remember I said sort by name or count. You can control if this variable has a sensitive data or not, so it can flag out some insights or some other variables that might be acting as proxy to this sensitive variable. And again, you can do the bucketing or add the rest of the possible values to buckets like others or etc. etc. And again, I can see month, and I'm looking at the distribution, by the way, or like, how many rows or observations per value. I come to duplicates. Duplicates is interesting. It's in the sense of saying, hey, I have detected that promotion and discount, and I'm just saying because I'm reading here discount and promotion. If I click here, it is discount and promotion. So yes, these are the duplicates. You might have a lot of more fields, and so you have to just read the message, which one is duplicate of what. And essentially saying here that hey, we're detecting that there's a similar behavior between promotion and discount in a simple way. Again, is saying, it looks like every time you use a promotion, let's say mail in, it happens to be a discount of 5%. Every time you use a promotion coupon, it happens to be a discount of 10%. So this is one of those things that I can take also a decision without going back to the business and saying, hey, is there like, understanding or agreement that you always run this promotion with this discount, because then those two variables are the same, and I need to take one out because Einstein's cover is not able, it's kind of getting confused to which variable of these two it assigns the power or the correlation or etc. So it is a good practice to go over these duplicates specifically and figure out if you need to include only one or both. Or again, the business might come and say, yeah, it's actually, we always run the same promotion with the same discount, so please consider one. Or they might come and say, no, we didn't know that, and that shouldn't be the way. So now we have to keep them together and figure out things again through the model metric comparison. And so that's pretty much it from the story setup. This is the screen you would have gotten if you have clicked on the manual when you created story versus automated, meaning automatically pick up the fields you need. If you have a data set with more than 50, like 100 or 200, and you said automatic, then Einstein Discovery will pick those 50 fields, let's say, or 30, whatever, and you will see a lot of fields here grayed out. So you will see like fields that are grayed out here, and you can come back and say, okay, I want to include this or not in the story. Another thing you will see typically in these kind of exercises, you will have a long list of variables, and you will have a call with the business analyst or the business experienced person, if you're not that person too, which you're going to go over each one by one variable and kind of, again, get those understanding. What is this variable? Is it always filled out or not? Maybe if I look at, I don't know, let's say a discount for some reason, and I will see a lot of records without a value. So that's also a decision to be made. Like maybe I shouldn't be including that field there. It's just not helping me. So those are things to consider. By the way, I do want to address the elephant in the room here. You will not have this field. This field is coming after we deploy our prediction or predictive field back into this particular data set. So you can check the deploy predictions in a recipe or data flow, and that's why you see this right here in my data set. You will not be seeing it, or in this story particularly. And the last thing on these, and again, you can go over the different insights, how you can look at it, etc. But the algorithms. So the Einstein Discovery detected daily quantity is a number. It's not yes or no. It's not 0 or 1. It's not binary. It's a linear regression, and it chose to use just a general linear model right here, which means that it detected that's a number, and we said it's a positive number, etc. But there is also the possibility of me coming here and saying, what, no, I know this particular data set, I want to run a GBM or XJBoost or even random forest, or maybe I just want to run a model tournament. And so Einstein Discovery goes over all these algorithms and picks the right or the best one for this particular story, and to give me the best model essentially. So of course this will take more time to run it, but again, if you're just starting with the product, I would just say go with what's being here presented, unless you know specifically why you want a random forest or XJBoost or GBM. Okay, so I am going to keep the same story. I'm not going to change it here much, and again, I encourage you to just keep playing around with the insights and kind of discovering, what's the story is giving us, those insights and explanations. So I'm gonna move here to predictions. And predictions is like your what if analysis at a crude level. So remember, in the beginning of this video, we went to the object, we created a new record that's sitting there waiting, for that action. We actually did that action to change the discount. And but I could have done the same thing here. So kind of like, let's say, well, for Boston, and but here I have to go with whatever I have here. So let's say, for May, and again, I don't know what promotion, so I'm saying no promotions. And let's say I want for this time for jerseys, and I want to know the discount. So I will mark one actionable variable, one variable that Einstein discovery can come back and say, okay, change this to XYZ, and you can get, ABC difference in outcome. So right now, what it's saying is for Boston, for May, no promotions, jerseys, you're gonna sell 811 daily quantity. That's a big number. That's a good number. You can actually push it a little bit more if you change to 10% or 20% or 5%. So I can choose whichever one I want. And when I say I choose, I mean, like, I can choose to change this right here, and that will reflect. But of course, this is not in production. This is not the end user. And that's why we want to, at the end, when we are okay with this model, to deploy it to production. This is just for me as again, super user trying to test stuff, or maybe presenting it for a different group. Notice when I changed it to 10, there were no more improvement. It was really high. Remember, the average is 335. For Boston, usually 700 or 800. And these are the top factors. These are the explanations. This is why we're predicting. So you can see all of the features we just talked about, how to read this chart, etc. And you can see that, well, if you're marking discount as a variable or actionable variable, these are your different choices and their impact. So you can, decide to. And the last piece here is the model. So this is the heavy data scientist, maybe, the closest to the data scientist part of this particular, story creation and model. So we see here it's a linear model. So I have an R-square. R-square is just kind of an indicator, and I want to keep conversation at simple level. There are other videos we go into the technical or advanced, what these mean. Sorry. And so the R-square, just roughly saying, so if you have anything between, let's say, maybe, I don't know, 0.79 or 0.8 to 0.85 is very good. But again, that's not the only indicator. It is a good indicator, the R-square, as I change edit the story settings. Like if I include city or take out city, I include promotion only, or I include promotion and display, or I take out the outliers. Every time I do any of those changes in the versions, in the different versions of the story, I always should take note of the model metrics. Is the R-square getting better? Is there anything else being affected? So again, R-square is one metric. Remember here it says 0.76, for example. But if you go to model evaluation here, or you click from here, I have the other metrics that are important, like the mean absolute error. So on average, I am 129 above or below my actual value. I'm predicting 129 above or below. And you can say, is this good or bad? Again, it depends, right? Now from the get-go, I'm going to tell you, if you recall, most of our values are between quantities we sell on those records between 0 and 500, let's say 600, right? Most of the values. So right now, this MAE is not so good, because what it's saying is, on average, you are over or under predicting by 129. So out of 600, that's almost 20% error, right? So on average, if the store sells 400 and you predict up to 129 above or 129 below, that could be a significant number. And again, it depends on the business. For stores that sell high values, always between 1,000 and 1,500, maybe 10%, maybe it's a fine number, right? But for stores who always or which always sell between 0 and let's say 100, this is a very bad metric, because I'm always 100% almost 100% wrong in my estimation or prediction. So this is where, again, the business knowledge with a little bit more statistics knowledge, you're starting to kind of understand maybe why I need to keep my eye on these metrics. You can look at the cross validation. So now we're talking about, we run the model 4 times and we get the average, and we see that there's no significant variance between these different fold or tests. So it passed cross validation, so it's okay to use this data set pretty much. And we have other other metrics. If you want to relate to your data scientist, or check with them on those metrics and what's their feedback. We can see the coefficient of every feature again, the value of that dimension. So San Francisco and 0, San Francisco by itself or month by itself, etc. So we have the individual variables and the pairwise interactions. And you can look at the prediction examination. This is a sampling of the 100 random sampled observations. I can see, like, this is the actual 206, predicted 353, not so good. Let me pick another one. And again, I can see that, okay, not sure why this is not updating. Yeah, it is updating. But again, I can see that this is not such a good model. And so maybe I'll just show you maybe a couple of ways how to go and try to check a few things. So first of all, let's say this outlier, right? So let's go to the outlier and say, you know what, I want to be very conservative, and I have 30,000 records, 25 and about 3,000. That's most of my records. So I'm going to say maybe maximum to 1,100. So just consider these records and update the story. And give me now the next version, right? So this, I would say, excluding daily quantity above 1100. Now, when this runs, it's going to run the story very similar, but the model metrics are going to be different, and maybe even some insights. The charts might have some different explanations, because again, I'm affecting the data set that I'm building this model on. So this is very important to consider. And this is the thing you will probably be doing a lot in the beginning, back and forth, changing these model metrics and checking each one what it's doing, and comparing these model metrics, the values. Now, while this is running, let's go back and discuss this model metric a little bit more. So notice that what we're going to discuss here is about the linear, not the logistic. So logistic regression, if you Google it, a couple of YouTube videos, and we have even blogs on this, but it is a little bit of a heavier topic. It involves a threshold and confusion matrix, and you really need to understand what you're trying to do, maximize or minimize, and what do you consider as a one, or positive or negative, etc. So for the linear model, and I do want to point out also that this chart actually, this is not reflecting the right residual, so just FYI. And what we're talking about here is the model metrics that, again, we discussed all of these. And again, a slight note that you can download the R code. Actually, I'll go back and show it to you, and you can run it, in a different environment if you wanted to double check on that. The MAE and the Rsquare. So the MAE, as I mentioned, is just like, how much you are above or below in general, and is it that acceptable for this particular data that you're dealing with? And the R-square is kind of a metric, and the simplest way one simple way to explain it is R-square is 1 minus the error by my model over the error by the taking the average as a prediction. So what that means is If I were to say, for Boston, for May, for jerseys, for promotion, this, well, we're going to sell 335. I took the average in general and I said, okay, that's my prediction. That will give me an error. When I go actually and sell and compare the actual data to prediction, it give me a certain error. Or I could use my model, which is predicting, let's say, in this case, it's 600 or 800, as you saw. It will also give me an error. But how do I compare, the risk of taking my model and using that to take business decisions versus taking the average? Well, Rsquare is your metric, one of those metrics. So if you think about it, if my model is very good, so my prediction is very close to the actual, so that means my error here is almost zero. Zero over whatever number is almost zero. So 1 minus 0 is a very high number. This is a 0.9, 0.95, 0.85. So the higher R square is, the closer it to 1. That means, essentially, it means that your model is very good. Okay, so far so good. The argument is okay. However, there is one problem with that, is if the lower number, if your average, if the error of the average is so big, if this number is big, if your average is really not really the average on usual circumstances, this number becomes very big, right? Like, let's say whatever that number is, and then doesn't matter what my model is, doesn't matter the error of the model, my error of my average is so big that this number becomes big. So all of this number becomes what? Small. Because it doesn't matter this number what it is, I have what I'm dividing by is a large number, so all of this number becomes very close to zero, and my R square is artificially inflated, and it looks like it's 0.9 or 0.95, and that should immediately should be a flag, by the way, that you don't usually get those kind of good numbers. And now R square is not indicating that my model is good. It just happened to be the average. The error of the average was so big that doesn't matter if your model is good or bad, it was just kind of masking that. And when does it happen that usually your error of the average is large? Usually when you have outliers. When you have outliers, things sitting out, of the normal, they push the red line, they push your average up, so your average becomes artificially inflated because you're including those stores that sold 2,000, 4,000 and 3,000. So when your average is including those outliers, then you have a bigger chance of having an artificially inflated R square, and you are in problem, especially with the linear model. And that's why typically when you have that linear model, when you're trying to increase, maximize, minimize a number, you want to pay attention to the outliers. We're not focusing on outliers, we're focusing on general trends. So we want to make sure that we are not including outliers in this particular scenario. Of course, like everything else, there's always scenarios where you might want to specifically focus on the outliers, but we're not covering this in this particular stage. And the last thing I want to show you, a true residual chart would look something like this. So ideally what you want is your actuals. These are your actuals, and these are your predictions. So you want them to kind of meet in the middle, right? So your actual meets your prediction, so you get that nice 45 degrees, or all your points are around this axis. Well, if you get something like this, well, okay, maybe this is again daily sales, and for lower selling stores or records, okay, the data looks to be consolidated. I do have some problems here, okay, but definitely I have a problem with the large daily quantity in this particular chart. And what I'm seeing is it's not really consolidated here. So I have some homework to do. One of the things, as you start picking up, just from experience, this might need a segmentation. So I may need a model just for stores or for daily quantities less than 1,000. I create a certain story, a certain model, and deploy it under that. and then I create another model, another story for daily quantity greater than 1000. I deploy it under the same prediction, but then what happens at the end user when they have a record coming in or when they are creating a record, whatever, if the daily quantity is less than 1000, model 1 gets applied. If the daily quantity is greater than 1000, model 2 gets applied. So as you can see now, we are getting into those complexities of which one to deploy, how many models I need to create, how's my story doing, etc., etc. And like I mentioned, there's way much more information you can check. There's actually two more advanced techniques and advanced topics on the model metrics. You can check them out in this series, or you can check this blog, or any other, again, general information about linear and logistic regression that you can check out again. Okay, so my story came back. Remember, this is the model where there's no outliers. So again, I mean outliers in the sense I excluded everything above 1100 daily record value. I have less number of rows, not a lot. I mean, if you think about it, I took out from 30,000 to 28,700. So okay, that's good. The insights are kind of still the same. City increased hugely to 47. Okay, but I'm gonna just skip these and kind of go focus on my R square. So the R square went down. I think it was 0.77 if I'm not mistaken, or 76. Not a lot, but what about my MAE? Okay, MAE is now down significantly. It was 129, right? And now it's 85. And the R square now is less, which is more realistic. Remember, so I took that error of the average, kind of made it better. And yeah, I think this probably is a better model. This is a better model performance, again, just based on these quick checks. And removing the outliers makes sense in this particular scenario, for example. So that's one way you can look at it. I do want to also mention that not every time whatever this is being presented to you or alert means a good thing. So for example, if we do take out city and we run the city, this is without let's say without city, we're gonna check the story again and let it run. And I am, again, just from previous times, because I ran the story, it's gonna actually give me a worse performing model. And that is the message that I want to relay, that you just have to pay attention that not everything as an alert makes sense to include. It could be whether it's business, whether it's by math, something else kicks in, or whatever it is. So you will do a lot of these iterations back and forth. So this is very important to keep in mind. And again, that idea, just to confirm or to reaffirm that, remember, for this particular model that I showed you had a better MAE. It was a better performance, but for records, it was based on records that had daily quantity less than 1,100. So maybe when I create this, so this story has been created with those records less than 1,100. I will need to create another story for daily quantity greater than 1,100 and study that model and say, okay, deploy that under that prediction. There's a property called segmentation. So again, like, it will know which record to go to. And again, we covered this. So this is the story back. Notice city is no more there. I have month, I have promotion discount item. And again, quickly, let me go to the model and see okay, look, R square is way much less. This is, very, very bad. And MAE is 164. So obviously this was not the right decision in this particular scenario. So I'm gonna go back to version history and say, you know what, I can delete this version and just go back to version 3, or I could have done it anyway, the other way around. I could also see, by the way, that anytime I'm switching stuff between versions, I can check it here. And the last thing I wanted to probably point out, that if I ran the story and created the model, everything's fine, and deployed the prediction as you will see in the other videos, and later on, maybe a week from now, I came back, opened the story, you will see mention here that if the data set, that daily sales data set changed or something changed in it or got refreshed, you will see a message asking you, to refresh the data to get the latest, etc. So that is pretty much how you can start your journey using stories, reading story, getting familiar with stories. I will encourage you again to load some data that you know of, whatever the business context. Spend some time on the insights. Spend some time on the component driver analysis. I think that's a very important chart to kind of get used to reading it, especially the why does this better. So this is very important, and start getting a little bit more familiar with this particular piece of it, the model evaluation metrics, what they mean, overview for the logistic, which means if you're trying to maximize, minimize a two value field, one true false, yes, no, 1 0, you will have a little bit more complexity. So you want to check that out. You can copy the R code, take it out, copy to clipboard. You can check the coefficients and run it on your own, in another environment. And there is one more feature I do want to point out that it's still beta at this time, but you can actually bring your own model. So you can also read the documentation about that, and you can bring the model and deploy it at the prediction deployment stages. But with that, I hope this is enough to get you started, especially just get the data in, run your stories, get used to the prediction models, and kind of go over in the next chapters how we're going to go over deploy models and the other properties.